Welcome to lecture number 33. So in lecture number 33, we are solving the problems of chapter 4 part 1, that is properties of Fourier transform, and we shall look onto inverse Fourier transform by using partial fractions expansion. The very first problem in this session is find the time domain signal given its Fourier representation as below. X of j omega, capital X of j omega is equal to 2 into j omega square plus phi j omega minus 9 divided by j omega plus 4 minus omega square plus 4 j omega plus 3. So this has to be solved using partial fraction expansion. So if we recall the concept of partial fraction expansion, we need to have a factors in the denominator. Here we have a factor, perfect factor. Here we need to do a factorization process in order to extract the factors of it. So to do it, so I extract this minus, I can write it as j square as well. J square is nothing but minus 1. So minus I treat it as j square. So j I take it in the square bracket, j omega square whole square plus as it is, rest everything as it is, 4j omega plus 3. Next I have to factorize it. It's very simple to factorize here, so I can directly do it. J omega square plus 3j omega plus 1j omega. 3 into 1 is 3, 3 plus 1 is 4. So I'll take j omega common here, j omega plus 3, and 1 common here, j omega plus 3. J omega plus 3 is one factor, j omega plus 1 is the another factor. So now we got the three factors of the denominator, this one, and this one. So I write the question given as the denominator, I change the quadratic equation in terms of the factors that we have just now found out. Now we need to apply the partial fraction method. So we apply partial fraction methods. So there we have three factors. So let me define three variables: a divided by j omega plus 4 plus b divided by j omega plus 1 plus c divided by j omega plus 3. Now, according to the rule of partial fraction expansion, we need to multiply by the denominator of your question throughout. If I multiply it throughout, so this and whatever comes in the numerator after multiplication get cancels, and I have to do the same process on the right hand side as well. So j omega plus 4 and this j omega plus 4 get vanishes. So let me check here. So j omega plus 4, see, so this gets vanishes here, so only numerator is left. Again I'll take whole of this and I multiply it with the a divided by j omega plus 4. So j omega plus 4 and this j omega plus 4 cancels. Other than j omega plus 4, you have j omega plus 1 and j omega plus 3 retaining it here. Similarly for b, j omega plus 1 will vanish, j omega plus 4 and j omega plus 3 will be retained. Similarly for c, j omega plus 3 will be vanished, the other two terms will be appearing. This is the second step of partial fraction. Now we shall apply the value for j omega such that two of the variables that we have just now defined should go to 0, and then we can apply the we can find out the remaining variable. So let me just take it here. Let j omega is equal to minus 4 in the first case. So if in this case j omega is minus 4 square is 16, 16 twos are 32, then 5 into j omega, 5 fours are 20, minus sign is there, this is minus 9. A, j omega is minus 4 plus 1 is minus 3, minus 4 plus 3 is minus 1, plus b into minus 4 plus 4 is 0, so everything goes to 0. Similarly minus 4 plus 4 is 0, everything goes to 0 here. So what is left is 32 minus 20 minus 29 will give you 3, minus minus plus 3a, rest everything is 0, hence the a value is 1. Similarly we shall apply j omega value as, now we shall retain b value. So 4 and 3, other than 4 and 3 we have minus 1. So let me substitute minus 1. We get it as, if I substitute minus 1 in minus 1 square was 1, 2 minus 5 minus 9 is equal to, so you have minus 1 plus 1 goes to 0, plus b, minus 1 plus 3 plus 4 is 3, minus 1 plus 3 is 2, so c goes to 0. So to minus 14 is minus 12 is equal to b into 6. So this gives you b is equal to 12 by 6 is minus 2. Similarly, let the other than minus 4 minus 1, we have minus 3 j omega. If we substitute minus 3, we get it as 9 2s are 18 minus here 5 3s are 15 minus 9 is equal to a vanishes, b vanishes. Now c's value is, we have substituted minus 3 plus 4 is 1, minus 3 plus 1 is minus 2. So we get it as 18 minus 15 is 3, 3 minus 9 is minus 6. This is equal to minus 2c. Therefore, c is equal to 3 is a answer. So I substitute a value as 1, b value as minus 2 and c value as 3 in the next case. So here I substitute x of j omega as, so I have written it with some intention, let me take it later. A value as 1 divided by j omega plus 4, and here it is minus 2, b value j omega plus 1, and c value is 3, j omega plus 3. So this is the partial fraction answer that we get. Now we have to apply inverse Fourier transform, inverse ft. So here I have given you the relation ft pair. So e raised to minus at u of t, where the ft pair is 1 by a plus j omega. We have solved this problem and we have used this a many number of times. So by this you can see here 1 divided by a space is occupied by 4 plus j omega. It is in this form. Hence, I can write x of t as e raised to minus 4t. U of t later we will write it minus 2 into e raised to, here in place of a I am having 1 minus t plus 3 e raised to, in place of a I am having 3 minus 3t whole bracket, we write it as u of t. So this is the answer for the question given using inverse Fourier transform by using partial fraction expansion. In the similar grounds, we shall have one more problem which is almost similar. So that's why I have the solution here. X of j omega is equal to minus j omega divided by j omega square plus 3j omega plus 2. This is a given equation. J omega square plus 3j plus 2 is the denominator. We need to factorize it. So factorization will result in 2j omega plus 1j omega. 2 into 1 is 2. 2 plus 1 is 3. So I take j omega common, j omega plus 2 will be left, 1 common, j omega plus 2. So these are the two factors. I write these two factors in the question, minus j omega divided by these two factors equal to two factors. Two variables should be defined, a divided by j omega plus 1 plus b divided by j omega plus 2. Now we shall substitute the value for j omegas, and then we shall proceed in finding out the value of a and b. So I multiply with the denominator, whatever denominator I am having, these two factors I multiply throughout. J omega plus 1, j omega plus 2 comes in the numerator, it cancels. It will come over here, j omega plus 1, j omega plus 1 cancels. J omega plus 2 will be written with a, and similarly j omega plus 1 will be written at b. So now we shall substitute, let j omega is equal to minus 1. So this value I'm choosing because I want to retain a, I want to make b's component 0. So if I substitute minus 1 here, minus 1 plus 1 cancels. So here minus of minus 1 is 1. 1 is equal to a into minus 1 plus 2 is 1. So therefore a is equal to 1. Similarly, if we substitute j omega is equal to minus 2, a vanishes. So minus of minus 2 is 2 is equal to a vanishes, b minus 2 plus 1 is minus 1. Hence b is equal to minus 1 is a answer. So with this we shall write the value of a and value of b. In place of a I am writing 1, in place of b I am writing minus 2. Here it is 2, hence minus 2. So this is a value. Now we shall apply the inverse Fourier transform. So in place of a I am having 1, so e raised to minus t. In place of a I am having 2, so e raised to minus 2t. This is a constant 2 whole in the bracket. So you write it as u of t. This is the answer for Fourier transform, inverse Fourier transform using partial fraction. So I want you to take one assignment. In the similar grounds, you can try it. Factorize the denominator, perform the partial fractions, and apply the inverse transform using e raised to at into u of t's ft pair. So that's all about your the topic inverse Fourier transform using partial fractions method. Now we shall look into some varieties, some different varieties of problems. Here, the question goes like this. Identify a system given its input and output. X of t is equal to e raised to minus 2t u of t, and y of t is given as e raised to minus t u of t. So you need to find out what is the system. Impulse response. This is system, impulse response. Input for the system is x of t, output is y of t. So you need to find out its value. So let the solution goes like this. So you know that I'll take x of t is equal to e raised to minus 2t into u of t. By the standard ft pair e raised to minus at u of t, we can write it as capital X of j omega as 1 divided by a plus j omega or j omega plus a. So here in place of a I'm having 2. So let me write it as 2. Similarly, y of t is equal to e raised to minus t into u of t. So its ft pair is capital Y of j omega, which is equal to 1 divided by place of a I'm having 1 j omega plus 1. So now h of t's ft pair is its ft pair is h of j omega, so which is written as y of j omega divided by x of j omega. Right? This is how the system is written. So now I'll take y of j omega here, 1 divided by j omega plus 1 into x of j omega is in the denominator, so I write it in the other way. So this is how I write it. So therefore h of j omega is equal to, what I do is I take, so this j omega I apply to both of this component. For j omega divided by j omega plus 1 plus 2 divided by j omega plus 1. So I can write it in any form. So in this form. So let me write it in this man. So j omega plus 2 divided by j omega plus 1. So we can write it in many ways, or else in other way, in the simplest way is I split it in this way for my easiness. So I apply j omega plus 1 as one component, plus the remaining is the other component. We have a number of methods to do it, so I prefer this method. Therefore h of j omega is 1 plus 1 divided by j omega plus 1. This is h of j omega, system operator in frequency domain. Now if you take inverse Fourier transform to it, we get it as h of t. What is inverse Fourier transform of 1? Inverse Fourier transform of 1 is delta of t. We know it. Plus inverse Fourier transform of 1 divided by j omega plus 1. Here it is. This is e raised to minus t into u of t. So remember, 1 and delta of t are ft pair. So in frequency domain you get it as 1, in time domain it is delta of t. So this is the system function or h of t. Now we shall take the next one. So here you need to find the Fourier representation of the time domain signal. X of t is given as e raised to minus 2t into u of t minus 3. So here what you need to do is you need to apply properties wherever it is necessary. Let me just go in detail. So here the formula used is capital X of j omega, integration from minus infinity to plus infinity, x of t e raised to minus j omega t dt. So here in place of x of t I substitute e raised to minus 2t u of t minus 3. So this one is e raised to minus j omega t dt. So now what I do is I change the variable, change of variable for integration. Here what I do is I substitute t minus 3 is equal to 2. So hence t is equal to tau plus 3. This is a change I am supposed to do it now. So I get it as a, so here you know that. So when I do it, when I do till tau is equal to 0 to infinity, I get, because when t is equal to 3, so tau will be 0. So hence I start, because this exists from t is equal to 3. Hence when t is equal to 3, tau is 0. So I take tau from 0 to infinity. E raised to minus 2. In place of tau, I write it as, in place of t, I write it as, one second. In place of t, I write it as tau plus 3 u of tau e raised to minus j omega. In place of t, I write it as tau plus 3 d tau. This is what I got. Now let me simplify it. E raised to minus 2 into 3 is minus 6. That's a constant. I'll take it outside. Integration from 0 to my infinity. So you get it as e raised to minus 2 tau. U of tau is nothing but 0 to infinity. It exists. I have already taken care. Leave it. So e raised to minus j omega 3, I write it. E raised to minus j omega tau, I write it d tau. So here again e raised to minus j omega 3 is a constant. I write it as, I take it outside. So what is left is e raised to minus 2 tau and e minus j omega tau. So I write it as minus j omega plus 2 tau d tau. This is how I write it. So this is equal to e raised to minus 6 e raised to minus j omega 3 into, so take its integration, e raised to minus j omega plus 2 tau divided by, there is a minus sign coming out, so minus j omega plus 2. So this is what you get. Now we have to substitute the limits. So if you substitute the limits, you get it as, so e raised to minus infinity is 1 divided by e raised to infinity is 0. E raised to minus infinity is 0. E raised to 0 is 1. So substitute tau equal to 0. E raised to 0 is 1. 1 divided by, so I write it as minus 1 divided by minus j omega plus 2. So I take the next slide. So therefore x of j omega is equal to, you can see here, minus and minus cancels, only this divided by this I get. So I write it here, e raised to minus 6 e raised to minus j 3 omega divided by j omega plus 2. So you can write it in the fashion you want. So I can also write it as e raised to minus 3 2 plus j omega divided by 2 plus j omega. This is also okay. So this and this I have combined. Okay. So this is the answer for the question taken. Now we shall move to the very next section. So in the next section, we have verify the differentiation property. So we are taking the problems on various properties now. So should be very cautious here. We are using the answers of one of the question or one of the problems in future questions to solve it. So here we have been asked to verify the differentiation property d by dt e raised to minus 8u of t. Its ft pair has been given. You need to verify its result. So quite simple, because we already know what is the ft pair of e raised to minus 80 e raised to minus 80 into u of t. We have just now checked. Its ft pair is 1 divided by a plus j omega. We already are aware of it. Now I take this question, d by dt of e raised to minus 80 into u of t. So if I take its differentiation, there is I have to take its differentiation now. So you get it as minus a e raised to minus 80 into u of t. Next, because I have taken u of t outside, of the outside, and differentiation of e raised to minus 80 yields e raised to minus 80 into minus a. Now I take e raised to minus 80 outside. Differentiation of unit step function. Differentiation of unit step function, we have studied about its properties. It will give you delta of t, or else this can also be written as minus a e raised to minus 80 u of t. Here this delta of t exists only for t is equal to 0. When t is equal to 0, this delta of t exists. So if I substitute t is equal to 0, you will get it as e raised to 0. E raised to 0 is 1. Hence I can just write delta of t. Just write delta of t. Okay. So taking ft of each term, and using linearity property, we get it as d by dt of e raised to minus 80 u of t's. Each term ft, we get it as, so take the ft of this. Minus a is a constant, and you know that e raised to minus 80, its ft is 1 divided by means 1 into a is minus a divided by a plus j omega. So minus a is constant. You know, you have the answer already. And the Fourier transform of delta of t is 1. We have already checked in. So I take this onto the numerator. So a plus j omega divided by a plus j omega. A and minus a cancels. You get it as j omega divided by a plus j omega. So remember, this property we'll be using in future. So differentiation of e raised to minus 80 u of t will get you j omega divided by a plus j omega. This is the answer. Now we have a question. Find the Fourier transform of Signum function. We have already analyzed what's the meaning of Signum function, how it is represented as Sgn of t. So Sgn of t, Signum function is 1 for t greater than 0 and minus 1 for t less than 0. So we need to find its Fourier transform. So to find its Fourier transform, the very first thing is I shall write it as, just here, Signum function can also be denoted as 2 into u of t minus 1. 2 into u of t means, u of t. So it is like this, u of t. So I make its amplitude 2. Okay, from 0 to infinite. Now minus 1 if I do, this amplitude will reduce to amplitude 1. So I got it 1. Here it is 0. Here u of t is 0. So this term is not there. Only minus 1 is there. So minus 1 till minus infinity. So Signum function can also be represented as 2 into u of t minus 1. So remember that. So I write it here. Signum function can be represented as 2 into u of t minus 1. So now to make the job simple, what I do is I take its differentiation. If I take its differentiation, 2 is a constant. Differentiation of u of t is delta of t. We already are aware of. And differentiation of constant is 0. It vanished. Let me call it as 1. This I'm taking just for simplicity. Okay. So x of t's ft pair is capital X of j omega. Now x of t's places Signum function here. Okay. So d by dt of Signum function is, its ft pair is, so if it is d by dt of x of t, we would have written j omega into x of j omega. That's a differentiation property. So hence I write it as j omega capital X of j omega is the answer. So differentiation of this. Okay, but I name it as 2. Look at equation 1 and equation 2. I can bring out some usefulness here, some simplicity here. So I write it here. 2 into delta of t. If its ft pair is taken, you get it as 2. J omega x of j omega. It is equal to 2 because from 1 and 2. Just look here, using the properties, making my problem very simple. So this said that differentiation of signum function is nothing but 2 into delta of t. So 2 into delta of t's ft pair is j omega x of j omega. That is what is the meaning of equation 2. So I combine these two things. Okay, so I write it as, it's like 2 delta of t and j omega plus j omega x of j omega. Its ft pair I can equate. Hence I write it as 2 here. So if I write it as 2 here, so I am asked with the answer x of j omega. So I take 2 by j omega on the other side. So you get this answer as 2 by j omega. So here you need to note Signum function. So ft pair is here. So note I have here written. Note that Signum function is an odd function and therefore its Fourier transform is pure imaginary function of omega. It's a pure imaginary function, and you know that Signum function is a odd function. It's anti-symmetrical. So we have studied it in symmetrical properties. So everything you should be able to relate. Then only you can enjoy this subject. So this is all about the Signum function's Fourier transform. Next is, using integration property, find the Fourier transform of u of t. So u of t's details we already know. Let me write the integration formula. Integration x of 2 d2 is equal to, its ft pair is 1 by j omega x of j omega plus pi j x of j0 delta omega. So u of t is also represented as, differentiation of u of t is delta of t, and u of t is nothing but integration minus infinity to t. This is called running integral of delta of t d2. We have delta of t is equal to 1. This is ft pair. This is ft pair. Setting x2 is equal to delta of 2 in equation, we have x of j omega. X of j omega is equal to 1. Okay, x of j omega is equal to 1, and x of 0 is equal to, capital X of 0 is equal to 1 because it's a delta function. So using these two things in the formula that has been mentioned, you can see here, in place of x of j omega, I substitute 1. So in place of j omega, I substitute 1. What is left? 1 by j omega is left. I write it here. Plus pi into, what is capital X of j0? Capital X of j0 is capital X of 0, which is equal to 1. So I write it as 1. So what is left? You have only delta of omega. You have only delta of omega. That is what you are supposed to do. Okay, so this is the integration property applied for finding out the Fourier transform of u of t. So Fourier transform of u of t is given by pi delta of omega plus 1 by j omega. Now, find the time domain signals of x of capital X of j omega is equal to e raised to j4 omega divided by 2 plus j omega whole square. Now here I just take few things for the analysis. We had solved one problem in the previous session of lecture 32 while explaining the differentiation property, that when the question is x of t is equal to t into e raised to minus at u of t, you know that e raised to minus at u of t is ft is 1 by a plus j omega. So when I put this t, so what was the change we observed? We could solve the problem in this fashion. X of t is equal to t into p of t. We called it as p of t, and p of t is nothing but e raised to minus at u of t. So hence p of t is a Fourier transform 1 by a plus j omega. Now using differentiation property, we could write it as minus j t p of t. Minus j, we took it out on the other side. T p of t, we got it as differentiation in the frequency domain of Fourier transform of p of j, and we could solve it as 1 by a plus j omega square. This is a ft pair. This is a ft pair when your time domain signal is t into u e raised to minus at into u of t. Now using these things and also using the time shift property, this is time shift property. What does time shift property tells? X of t minus t naught, x of t minus t naught, its ft pair is, whenever you take this time shift property, time shift in the time domain, we'll introduce an exponential component e raised to minus j omega, whatever amount of t naught, that value will come over here into capital X of j omega, that Fourier transform. Using these two things, 1 and 2, we solve this problem. The problem is here. The very first thing, this and this, I use it here. Replace, see, in place of t naught, I am having 4, and in place of a, I am having 2. Replace a with 2 and t naught with 4. See here, in place of e raised to, in place of t naught, I am having minus 4, and in place of a, I am having 2. So a plus j omega whole square, in place of a, I am having 2. So I do this much. So what I get? I get as e raised to j 4 omega divided by 2 plus j omega whole square, its ft will result in, so just check what I do. So this is this and this I have to combine. I write t e raised to minus at. I have to write, in place of a, I write it as 2. In place of t, I write it as t minus t naught, t minus of minus 4. T minus of minus 4 is plus 4. T plus 4. In place of u of t, t plus 4. That's it. We used 1 and 2, and we could find out the inverse Fourier transform of this complicated question of frequency domain signal in a very easy steps by using the Fourier transform properties. One is differentiation property and the other is time shift property. You get the answer in this manner. Very simple. So use of the property will help you to solve the problems in a quicker and easier manner. But you should be knowing like how to use it in an efficient manner. To use it, you need to understand and you need to remember it. And you should also know like when, what should be used. So now, use the differentiation property to find ft of the following signal. Okay, so here it is given as d by dt e raised to minus 2 of t. So this is mod t. I don't know whether you remember or not. We had solved a problem. To illustrate you what is the ft pair of e raised to minus 2t. So we had solved it. So let me show it. So in chapter 3, let me show it. I have just opened it here. So in chapter 3, this is chapter 3 PPT. So we had solved it here. X of t equal to e raised to minus mod t. So we have to take its Fourier transform. We could solve it and we have got it as 2 divided by 1 plus omega square. 2 divided by 1 plus omega square for e raised to minus mod t. So that I write it here. Same thing, I'll write it here. The problem is you need to remember all these things. That's the only thing is a complicated one. E raised to minus t, its ft pair is 2 divided by omega square plus here whatever I'm having 1 square. That's how you need to write. Okay, so here if you have some number, that you have to write it here. That's how it goes. Okay, now I am having e raised to minus 2 and t here. So for this, the ft pair is, in place of 1, wherever you have 1, you write it as 2 because you have 2 here, divided by omega square plus 2 square. This is what you get. So hence, differentiation property again I write it here. d by dt x of t, its ft pair is j omega capital X of j omega. So hence I take this d by dt e raised to minus 2 t, its ft pair, write it combining this and this. I use these two things and write the answer. j omega, because differentiation is there, j omega component comes. Now x of j omega, it is already here. X of t is, if I consider this as x of t, x of j omega is already there. So you have to write it as 2 into 2 divided by omega square plus 2 square. So therefore, capital X of j omega, this is standard forms, okay? These are standard forms. This is a problem. See how small the problem is. 2 2s are 4, j omega divided by omega square plus 4. That's it. Your solution is done. This is your answer. 4j omega divided by 4 plus omega square, or omega square plus 4. That's the answer. Now in the similar grounds, we have one more problem. So d by dt of x of t, the differentiation pair is given here. Now you have to take this t into e raised to minus 2t u of t. So for this, I write the ft pair t into e raised to minus t u of t's ft pair is, we had solved it earlier, I'll show it. We had solved it earlier. Yes, here. I had shown it. T into e raised to minus at, its ft pair is x of 1 divided by a plus j omega whole square. I had told it that we'll be using it in future problems. 1 divided by a plus j omega square. So here I use the given thing, 2 into t e raised to minus 2t u of t. So in place of a, I am having 2. So constant 2 is also there, 2 divided by 2 plus j omega whole square. So this is the problem. Now using the differentiation property, j omega will be extracted outside. So capital X of j omega is equal to j omega, and its d by dt is taken care with this j omega component. 2t e raised to minus t u of t's ft pair is here, 2 divided by 2 plus j omega whole square. So here's the answer, 2 into j omega divided by 2 plus j omega whole square. Very simple problem. So this is how you need to solve using the properties, differentiation property. Now, so here we have a comparatively bit complex problem using time differentiation and convolution property to find out the ft. So here we have a convolution property. So I have to use differentiation property as well. So what I do is I simplify it. D by dt, I call it as P of t, this one. And for this one, this is convolution, I call it as Q of t. Okay. So in total, I call this as X of t. Okay. So d by dt of x of t's ft pair is j omega capital X of j omega. You already know it. And p of t convolved with q of t. So if convolution in frequency domain becomes multiplication, p of capital J omega, capital P of j omega into capital Q of j omega. This is what happens. Now capital P of j omega means what? T into e raised to minus 3 u of t. Just now we derived the formula for it. What is that? 1 divided P of j omega. P of j omega is here. 1 divided by a plus j omega whole square. A means 3 here. 3 plus j omega whole square into Q of j omega's Fourier transform is e raised to minus at form. 1 divided by a plus j omega. That's it. In place of a, I'm having 2. 2 plus j omega. That's it. This is. Now, we are not at complete because it is p and q only. So at we need to do complete it using this one. So therefore, capital Y of j omega is equal to, actually this is capital Y of j omega is equal to, and this is y of t actually, you can see capital Y of j omega is equal to j omega into capital X of j omega, which is nothing but p of j omega into q j omega. So I write it as divided by 3 plus j omega whole square 2 plus j omega. The same is the answer. Okay, so using the properties made my job very simple. So Only thing is you need to apply your knowledge accurately at right places. Now, find an FT by using frequency shift property. They have mentioned it. Use the frequency shift property to find the FT. Solution goes like this. This is a question. E raised to j 10t is a question. Okay, so this problem we can solve it in a very simple manner. We may express z of t as a product of complex sinusoid and rectangular pulse. So what they are saying is this can be represented as a rectangular pulse minus pi till pi 1. Let me call it as x of t. This is x of t. Now I multiply it with e raised to j 10t. 10t. So it's as good as writing like this. So hence I take x of t separate, e raised to 10t separate. So z of t is product of e raised to j 10t into x of t. This is how I am taking, because I can apply frequency shift property very easily. And x of t, rectangular pulse, its Fourier transform we already know. This is the rectangular pulse, and the standard equation goes like this. Capital X of j omega is equal to 2 sine of omega t naught divided by omega. So what is t naught here? In this place t naught is pi. In this place t naught is pi. And we also know that frequency shift property. This is frequency shift property. Okay, using these two things, see, you can directly apply e raised to j 10t x of t can be applied in this way. So frequency shift happens. That's it. So what I do is, using this result, what I do is x of t's ft pair is 2 divided by omega. So 2 divided by omega sine omega t naught. In place of t naught, I am having pi. That's it. Now I introduce this multiply with this exponential term, complex sinusoid term, e raised to j 10t. So when I multiply it with e raised to j 10t, so here like this for x of t, in the frequency domain, it will get shifted. So omega will be shifted by gamma times onto the right. So that's why we write it as omega minus gamma. In place of gamma, I am having 10. Hence, I have to write it 10 here. Okay. So now x of j omega is here. Replace omega with omega minus 10 everywhere. So that's your answer. 2 divided by, in place of omega, I write it as omega minus 10. Sine of, in place of omega, I write it as omega minus 10, and pi as it is. That's it. This is your answer for frequency. What is that? Find Fourier transform of complex sinusoid pulse. This is called complex sinusoid pulse. I hope there are no doubts. Now the next question. Here, using the frequency shift property, find the time domain signal. So frequency domain signal is given. You need to find the time domain signal. So frequency shift property tells that e raised to j gamma t x of t shifts in terms of frequency in the frequency domain. X of j replace omega with omega minus gamma. Now we shall proceed in this way. Solution goes like this. 1 by 2 plus j omega's ft pair is, in place of 2 I am having a earlier. So e raised to minus 2t into u of t. We are very well aware of these things now. Now, the other one is also same. This is also same. We know that x of j omega minus gamma. In place of gamma, I write as 3. If I write it in this manner, so what actually happens in the time domain? Additional component gets added. So e raised to j. So gamma value is 3 here. 3t. And rest of the equation as it is. E raised to minus t, 2t into u of t. Because this I call it as x of, let me call it as x1. x1 of j omega. x1 of j omega I call it as. So now, similarly, if I take x1 of j omega plus 3, if I take, I get it as, here it is minus 3 now, e raised to minus j 3t, rest as it is, e raised to minus 2t u of t. Now it is added, these two things are added. So if I add it, add it, it becomes capital X of j omega. So its ft pair is, add both of things, add both of things. Here e raised to minus 2t I'll take common, into u of t I'll take common. What is left is e raised to j 3t plus e raised to minus j 3t. You can use the Euler's theory in order to find out the x of t. E raised to minus 2t u of t. This is 2 cos theta. In place of theta I am having 3t. So hence your final answer is x of t is equal to 2 into cos 3t into e raised to minus 2t u of t. This is your answer. Very simple. Next, so be cautious here. Here the problem is very, it requires a lot of concentration. Using multiplication property, find the time domain signals of the given question is frequency domain. Capital X of j omega is equal to 2 sine divided by something. Here exponential term is there, sine is there. Whenever you get sine divided by something omega, so you have to link it with rectangular pulse in the other domain. Whenever you get some exponential sinusoid, complex sinusoid term multiplied with some standard things that is known, then it is frequency or time shift property. So both of the things I have written here. This is rectangular pulse, rectangular pulse things. So x of t 1 for t less than or equal to t naught. If you take its ft pair, you get it as capital X of j omega is equal to 2 sine omega t naught divided by omega. So it is somewhat resembling both of things. And similarly, you know that e raised to minus j 2 omega is a it is in the frequency domain. In time domain, it will add a term. It will multiply. It will introduce a time shift that we will look into shortly. We'll look into it. So here I start with a solution. So 2 into sine omega, this one is already there. I just write the first term, omega minus 2 divided by omega minus 2. Its ft term is x of t is equal to 1 for t less than or equal to 1. Okay, less than or equal to 1. And similarly, here it is otherwise. Okay. And if I want to draw this x of t, so this will look in this fashion, minus 1, 1. And if I want to take the next one, this one, e raised to minus j 2 omega sine of 2 omega divided by omega. So it's ft pair. So I should have 2 here. So 2 is missing here. So I introduce 2 here. That's why to compensate, I'll take 1 by 2. Okay. So to compensate, I'll take 1 by 2 on both sides. So that 2 is added here. Now for this, x of t is, I can write it as the other way. Let me write it as x1 of t. It has x1 of t, x2 of t as 1 by 2 into x2 of t as here there is a the component. To compensate it, I should have a time shift by how many times? Here it is 2, so 2 times. This will give you 1 for t less than or equal to 2, because I'm having t naught 2, and this 2 is because of the, one second, this is because of the time shift property. This is otherwise. Okay, so we have all the things that is needed. So x2 of t minus 2 will look as, first we will see x2 of t. X2 of t means for t less than or equal to 2 means this is how the x2 of t is there. X2 of t minus 2 is shift by right 2 times, 0 to 4, and we are convolving here. Convolving becomes multiplication in the frequency domain, so multiplication in the time domain. So you can check When I multiply this signal with this signal x1 of t, it is -1 to 1, this is 0 to 4. So overlap is only this part. So hence overlap is only from 0 to 1. So we write it as x1 of t, x2 of t, overlap is only from 0 to 1. We can write it as u of t into u of t minus 1. Okay, for this what all things components I need to add here. So I need to add, so there was 1 by 2, so 1 by 2, so that 1 by 2 I am adding, and there here it is a omega minus 2, so there is some frequency shift. To compensate it for x1 of t, I need to write e raised to j here 2t, because in the frequency domain if you have shift, in the time domain you have to introduce this component. In frequency domain if you have this component, in time domain you have to shift. So that's why it is quite confusing. So they have introduced this complexity here. Okay, so this is equal to, and you have 1 by 2 pi as well, 1 by 2 pi as well here. So 1 by 2 pi, so 1 by 2 is already we have compensated, so hence you will be left with only pi. So therefore I write it as here in detail 1 by 2 pi, this question x of j omega is equal to its ft pair is this 1 by 2 pi. What I do is I take it on the other side, because I don't have 1 by 2 pi here. 2 pi, I write it 1 by 2 e raised to j 2t u of t minus u of t minus 1. Okay, so 2 and 2 cancels, so therefore x of t is equal to pi only is the left thing, e raised to j 2t u of t minus u of t minus 1 is your answer. Bit complex, but if you go through it once or twice, and if you write it and practice, then definitely it will be understandable. The same answer. I had reserved one more slide, and because this problem is big, but I could solve it in single page. So this problem, it is almost again differentiation is there. You have e raised to minus 3t is there. You have e raised to minus 3, frequency shift is there, time shift. We identify 3 properties required to solve this problem. One is differentiation, one is convolution, because there is a convolution, and time shifting. So let w of t is this one. This I treat it as w of t. This I treat it as v of t. Differentiation of w of t convolved with v of t. That's how we can take it as. So x of t is equal to differentiation of w of t into v of t. Hence, applying the convolution and differentiation property, what we can do is differentiation can be in the ft pair, we get a component j omega, and this convolution becomes multiplication. So we know that w of j omega is very easy to write. So w of j omega is 1 divided by 3 plus j omega. That's it. This transform pair we already know, e raised to at u of t. Its transform pair we already know, a plus j omega. So we replace a with 3, we get w of j. And similarly, we replace a with 1, we get v of t, but there is a u of t minus 2. Time shift is there. Time shift, to compensate time shift, we need to have a component complex sinusoid e raised to j 2t. So w of j omega is done, 1 plus 3, 1 divided by 3 plus j omega. Now we have same transform v of t, so we get this e raised to minus 2 component. So what I'm doing is I'm taking the same e raised to minus t u of t minus 2. You just check here, e raised to minus t u of t minus 2. This is actually v of t. What I'm doing is I'm having multiplying with these two things. It cancels actually. So e raised to minus 2 I'll take it outside. This I take it inside. Minus is taken common, so t minus 2 we will get it as. So why I'm taking like this? Because for this I can apply frequency shift operator, time shift operator. Thus v of j omega is, this is a constant, take it outside. So for this, e raised to minus j2 omega is a component which will compensate for the time shift in the time domain. So divided by, in place of a I'm having, just in front of t I'm having 1 plus j omega. So w of j omega we had got it as earlier as this. So we need to multiply now. So when you multiply, so I had shown it as x of j omega is equal to v of j omega into w of j omega. So when you multiply, you get it as these things, and we had j omega component as well. I'll show it. So j omega into these multiplication. So that is what we are doing, j omega into these multiplication. So j omega is here. So rest of the component, e raised to minus 2t 2 e raised to minus 2 j2 omega. So in the denominator we have these two factors. So this is the answer. We could use three different properties: shift property, convolution property, and differentiation property in this problem. The next one is regarding scaling property. The signal x of t has a Fourier transform given. So Fourier transform is already given. Capital X of j omega is already given. Without finding x of t, find the Fourier transform of x of 4t. It has been scaled. So scaling should be done without finding x of t. Don't find x of t. Directly find out x of 4t. We know that scaling factor z of t is equal to x of at. Its Fourier transform is 1 divided by a, its mod, negative sign you should ignore here, x of j omega by a, don't ignore negative sign here. So here what we do is, we have to take, I write it here, x of 4t, its ft pair is 1 divided by 4 capital X of j omega divided by 4. This is what we need to do now. Just check here. Same thing, 1 divided by 4 capital X of omega by 4. So here the ft is already given. So 1 by 4 is taken here, 1 by 4. Phi as it is, 1 plus, in place of j omega, I am writing j omega by 4, j omega by 4. Here also same thing, 8 as it is, minus omega, in place of omega I need to write j omega by 4. So j omega by 4. So j omega square is omega square. You get omega square divided by 4. For 4 you will get it as 16. 4 square is 16 plus 6, in place of j omega I need to write j omega by 4, j omega 5 by 4. So this 4 and 16 are in the denominator. In order to compensate it, what I do is I multiply by 4 throughout. So hence we get it as multiply by 16 throughout. So when I multiply by 16 throughout, we get it as in this fashion. You can do it. This simplification you can do it. Okay. So this is the answer. My job is here to just to make you aware that how properties help us in order to solve the problems, difficult problems, in an easier way. Okay. Next is find ft of some equation is given here, e raised to minus j omega mod omega e raised to minus some complicated thing is here. Without determining x of t using scaling property, you should find out y of t is equal to x of minus 2t. So y of t you need to find out. What is that y of t? X of minus 2t. So x of t's Fourier transform is already given. You need to find out the next one. So here Fourier transform of, this is solution, Fourier transform of x of minus 2t, which is nothing but y of t. We can also write it in this manner. It is 1 by, there is mod 2. You already aware that it is mod a. Mod 2 means negative sign can be ignored. Capital X j omega divided by a. Divided by a is minus 2. So minus should be there here. Minus should be there here. Hence I write minus here. Okay. So minus should be present. So this is equal to 1 by 2. X of j omega is already given. Wherever omega is there, I substitute it with omega by minus omega by 2. E raised to, wherever omega is there, I substitute, I can write it here. Okay. Omega is replaced by minus omega by 2. Minus and minus cancels, j omega by 2 in place of omega. So mod is there, hence ignore negative sign, omega by 2 e raised to minus 2 minus 2. In place of mod, again negative sign should be ignored, omega by 2, omega by 2. This 2 and this 2 cancels. So hence you get the answer as y of j omega as 1 by 2 e raised to j omega by 2 omega by 2 mod e raised to minus mod omega. That's it. This is your answer. Okay, how simple it is using the property of scaling. So next, again, we have the rectangular pulse. Scaling of rectangular pulse you need to make. We have been given two rectangular pulse. Let me draw this rectangular pulse here. Minus 1 to 1, your amplitude is 1. So this is x of t and this is y of t. This is minus 2 to 2. Here it is 1. So you know that the standard equation given is this ft pair is 2 sine omega t naught by omega. Okay, and scaling properties x of at is equal to 1 by mod a capital X of j omega by a. Substituting t naught equal to 1 for the first case, t naught in place of t naught I am having 1, I get 2 sine of omega divided by omega. 2 sine of omega divided by omega. That's x of j omega. It's done. Now we come to the y of j omega. So y of t is x of t by 2. So it's been scaled. Y of t is x of t by 2. So it's been scaled. So t by 1 by 2. So divided by 1 by 2. 1 divided by 1 by 2 means 2. Minus 1 divided by 1 by 2 means minus 2. So this has been scaled. So using scaling factor we need to do, right? So in place of a, I'm having 1 by 2. 1 divided by 1 by 2 is, in the numerator you get it as 2. Here 1 divided by 1 by 2 is x of j 2 omega. So replace a with 1 by 2. I get it as 2 into x of j 2 omega. So 2 is a constant, take it outside. So wherever you have omega, replace it with 2 omega. That's it. That's the answer. 2 is taken outside. 2 divided by wherever you have omega, you write it as 2 omega sine of 2 omega. The final answer is 2 cancels, 2 by omega into sine of 2 omega. That's it. Very simple. Using scaling function, we could do it in very easy way. Here the same extension. So this is x of t. This is y of t, which is a scaled version. Scaled version. This is capital X of j omega. This is capital Y of j omega. You know, in the time domain, the signal is expanding. In the frequency domain, the sinc function, you can see that it is truncating. So these are the observations you need to make. Next, use the multiple property to find an inverse Fourier transform. Again, you see here, you have differentiation in frequency, and then you have many components here. We will do it. Scaling function is also there. So here, one second. Okay. We have a lot of equations. Let me simplify it. Let me take S of t as e raised to minus t u of t. Its ft pair is 1 divided by 1 plus j omega. This is a standard form. We already know it. X of j omega. This x of j omega can now be written as j d by d omega e raised to j2 omega. Excuse. S of omega is replaced by omega by 3. J omega by 3. Omega is replaced by omega by 3. Very simple. Again, I simplify it. Here, whole of this term, I call it as W of j omega. One more simplification. W of j omega is equal to e raised to j omega. This S of j omega by 3, I call it as Y of j omega. See, the same equation I'm representing in this way. See here. S of j omega is nothing but y of j omega. Y of j omega and this together we call it as W of j omega. W of j omega differentiation these things if you add if you involve we will call it as x of j omega. Now I start with this particular thing, scaling factor. Using this scaling factor in the time domain, see, I compensate. What I do is I take something like 3 by 3. Okay, so this 3 is a constant. 1 by 3 s of j omega by 3 will resemble this. I'll write it as 3 into 1 by 3 s of j omega divided by 3. So this is resembling it. 1 by a x of j omega by a. Why? Because y of t I can write it as 3 is a constant. Take it outside. 1 by 3 side in this place I can write it as s of 3t in the time domain. X of 80 like that, s of 3t. Now s of t is nothing but e raised to minus t u of t. So hence I write in place of t I write it as 3t. 3 into e raised to minus 3t u of 3t. U of 3t means what? U of 3t and u of t both are same, because if you scale it by 3 still you get the unit step function as u of t itself. Hence you get it as u of t. So this is y of t. Remember 3 into e raised to minus 3t u of t. I'll take it to the next slide. So in the next slide we take time shift property. In time shift, if you do a time shift in the time domain, in the frequency domain this component gets involved, e raised to minus j omega t naught. This gets occurred, x of j omega. So w of j omega is equal to, from previous slide, w of j omega is e raised to j 2 omega. I don't show it once again, so you have already seen here. I just proceed. E raised to j 2 omega. E raised to j 2 omega. In place of t naught I am having minus 2. So hence in place of t naught I am having minus 2. So minus of minus 2 is y of t plus 2. So w of t is nothing but y of t plus 2. That's it. And y of t you already know it is 3 into e raised to minus 3t. In place of t I substitute it as t plus 2. In place of t u of t you will get it as t plus 2. Now I go for x of j omega. X of j omega is j into differentiation w of j omega. I use a differentiation property. So using the differentiation property, I get as x of t is equal to t into w of t. So t into w of t is already known. So t will be occurring in this component. So your answer is done. So that's it. So this is how you need to solve using the properties. Now we shall take the Parseval's relationship. So Parseval's relationship plays a very important role in order to simplify our job. So here we solve this example using properties. See here, I have already shown certain properties. Solution e raised to minus 1 mod t. Its ft pair. I had already taken it. It's 2 into 1 divided by omega square plus 1 square. Similarly, e raised to minus 2 mod t, wherever you have 1, put it as 2. That's it. So these two things are very important in order to solve it. Okay, and x of j omega can be written as 2 into 2 omega square plus 2 square. So I'll show it later. Its ft pair is e raised to minus 2 mod t. So this is here. So I could link it. Why I wrote it as x of j omega? Because let me write it here. Integration minus infinity till plus infinity. This 8 divided by omega square plus 4 square. I make some arrangements here. Sorry, 4 whole square it is, d omega. This I write it as 1 by 2. I take it common. If I take 1 by 2 outside, I have to write it as 16. 16 by 2 is 8 divided by omega square plus 4 whole square d omega. This is equal to 1 by 2 integration minus infinity till plus infinity 4 divided by omega square plus 4 whole square. I can write it in this manner. Why I am writing in this manner? Because now we arrive at this particular stage. So I can write it as 2 into 2 divided by omega square plus 2 square whole square d omega. So same component here I'm having. In time domain it is e raised to minus 2 mod t, that we have already understood. So with this understanding, what actually we are doing? We are applying Parseval's relation. According to the Parseval's relation, this one, Parseval's relation, either in the frequency domain you need to perform integration or in the time domain. So in frequency domain it looks complex. So what I do is, this one, I write it as, I take its ft and write it as, so in frequency domain I am having 1 by 2 pi, but here I am having only 1 by 2. This pi I'll take it on the other side in the time domain into integration from minus infinity to plus infinity x of t mod whole square dt. That's it. So here what I do is, I substitute the value pi minus infinity to infinity. Rather than taking from minus infinity to infinity, I take 2 times from 0 to infinity. Both are the same. Minus infinity to infinity or 0 to infinity 2 times. Both are same. X of t whole square dt. So I'll take this energy in the next slide. Therefore, energy is equal to pi into integration 0 to infinity. In place of x of t, I'm having e raised to minus 2 mod t mod of this whole square dt. Okay, dt. Okay, so this 2 I had missed 2. Okay, so this will give you, same thing is here, 2 pi. So 2 pi, same thing, you can relate it here. 2 pi, 2 into pi, integration 0 to infinity, e raised to minus 4t, because mod is there, square is there, hence you can write minus 4t. So 2 pi e raised to minus 4t divided by minus 4. This is the integration. Apply the limits. So you get 2 here. This 2 cancels. You get minus pi by 2. Substitute e raised to minus infinity becomes 0. Minus e raised to 0 becomes 1. Minus minus cancels. You will get it as pi by 2. That's your answer. Pi by 2 is your answer. Okay. So next is evaluate. In the similar grounds you have evaluate integration 2 divided by j omega plus 2 whole square. So solution goes like this. This is a Parseval's relationship. 1 by 2 pi integration capital X of j omega square d omega. This is equal to integration. So in place of this we have been given this. So I'll take 2 pi for compensating, because in the equation I'm having, so 1 by 2 pi, 2 pi, 2 pi, if it cancels, the same equation arises. Then I go on solving it. It leads to, so what I'm doing is, actually the formula says that it is square. It is square. It means x of j omega will be square root of this. If I take its square root, 2 into 2 is 4. Square root of 4 is 2. Square root of pi is square root of pi. Square root of this component is square, and square root cancels, j omega plus 2. This is nothing but x of j omega. So we can write, this is a constant. We know that what is its x of t? It is e raised to minus, in place of a I'm having 2t into u of t. Okay, so using this relation I can simply write x of t is 2 into root pi e raised to minus 2t u of t. You get it this? So what I do is I use this time domain for calculating the energy. So energy is equal to, in the time domain, so I use this component u of t 0 to infinity. That's why I'm changing from minus infinity to infinity to 0 to infinity, because u of t is there. Then your answer, you'll get it as pi. You can solve it by yourself. Actually 2 root pi, so e raised to minus 2t will get you u raised to minus 2t divided by minus 2. So you have to apply Okay, sorry, you have a square here. You have a square here. So I take the eraser. I take. So we'll write it here. So 2 square is 4. Root pi square is pi. Now integration of e raised to 0 to infinity e raised to minus 4t dt. So you get as 4 pi into e raised to minus 4t divided by minus 4 infinity till 0. This 4 cancels. You get minus pi outside. E raised to minus infinity is 0. Minus e raised to 0 is 1. So minus minus cancels. You get it as pi. That's your answer. Here it is. So this is the answer. Hope you have no doubts. Few more problems on Parseval's theorem. So quickly we will move on. It is very easy actually. Integration of a. This is a given equation. This is a given Fourier domain graph. So this is how it is. So you need to find out a. This is ft's definition. Capital X of j omega is equal to integration x of t e raised to minus j omega t. I compare the first question given. Minus infinity to infinity integration is there. X of t as it is. D of dt is as it is. Only this is missing. Only this component is missing means what? The meaning is omega is 0. You can assume that omega is 0. Replace omega is equal to 0 because when omega is substituted with 0, e raised to 0 becomes 1. So you get this equation. So when I substitute, because when you substitute omega is equal to 0, it will result in x of j0. So now substitute x of j0. So x of j0, x of j0 at 0, what is your value? This is omega equal to 0 value. Omega is 0. At omega equal to 0, what is the value? The value is 1. Okay, so the value is 1. That's it. Next, this b I'll take. So for b I use a Parseval's theorem because it is an energy equation. I use a Parseval's theorem. So what is given here is integration minus infinity to infinity mod x of t whole square dt. This is actually an energy equation. It's like find energy of this. Find energy of this. So let me show you. To find the energy, the equation is not simple. You need to find its equation. Its equation is omega plus phi. This equation is minus omega minus 1. This is minus 1, minus 3 to minus 1. Minus 1 till 1. The equation is omega plus 1. And this is minus omega plus 3. You know how to find this. Or let me just explain you one of the things. I take this one. So if I ask you to write its coordinate, what you write? Minus phi is x-axis, 0 is a y-axis. What is this coordinate? X-axis is minus 3, y-axis is 2. 2. Okay. So now I'll find out its slope. Slope formula is y1 minus y0 divided by x1 minus x0. What is y0? Y1 here 2. 2 minus 0 minus 3 minus of minus 5. So you will get it as 2 by 2, which is equal to 1. Slope is 1. Slope is 1. Now I substitute y is equal to mx plus c. Mx plus c. Y is equal to 1x plus c it is. Okay. Take any of these equation. Let me take minus 5 comma 0. Substitute it. In place of x I have minus 5. In place of y I am having 0. Here I get it as minus 5 plus c. So c you will get as minus 5 taken on the other side. C you get as 5. So hence the final equation I get it as y. A final equation I'll write it here. Y is equal to, in place of m I am having 1. In place of x I write it as x. In place of c I write it as y. Here y-axis is capital X of j omega. X-axis is omega plus phi. So this is in the range, I have taken this line, right? In the range minus 5 to minus 3. Minus 5 to minus 3. Omega in this range. So in this range, minus 5 to minus 3, I got it as omega plus phi. In the same fashion, you can do it for this line, this line, this line. You get in this way. Substitute it in this equation. Just solve it. Quadratic equation, you'll get it. Simplify it. That I leave it for you. Simplify it, you'll get the answer as 16 by 3 pi. You can cross check later on. Okay. Now the next one, C. Again, I'll take this C here, minus infinity and x of t e raised to j 3t dt. No Parseval's equation is used. So there is a, you cross check these things. Same integration, x of t dt dt e raised to j 3t. In place of omega, what I'm having? I'm having minus 3. That's it. That's it. So capital X of j minus 3. So at minus 3, what is your value? Your value is 2. So hence your answer is 2. Your answer is 2. This answer itself you need to write. That's it. Very simple. Next comes argument. So argument of x of t. So argument of x of t, actually, here you need to make some analysis. We need to analyze whether it is even function or odd function, and then we need to extract its phase. So if I have the signal like this, even signal of j omega, xc of j omega, I write it as, I shift it, so you can just check, because it should be even. This is a even signal. Okay, how this and this is related? This signal and this signal are related such that I take this signal, I shift it to the left one time, xe of j omega on to the left one time. Okay, so what I get? So I get it in this fashion. Frequency shift it is. Okay, that's why frequency shift. So I get in this manner e of j omega minus 1. So xe of j omega is real and even. Xe of j omega is real and even. Capital X of j omega is real and even function shifted by 1 to left. That is what is shown here. When it is real and even, your time domain signal will also be even and real and even. Thus, x of t is nothing but xc of t e raised to minus j of 1t. It can also be written as magnitude of xc of t e raised to minus j 1t. Why I'm focusing more on this? Because there is something called polar form. Polar form, we write it in this manner. This is magnitude, this is phase. In place of phase, I am having other than j, what I am having? Here xc of t mod e raised to j. Other than j, what I am having? Minus t I am having. Hence, argument of x of t is, in place of angle theta, that is argument of x of t is minus t. That's your answer. Next comes x of 0. So what is x of 0? X of 0 is not capital X of j 0. It is not that. It is time domain signal x of 0. So hence x of 0 is equal to 1 by 2 pi integration minus infinity to plus infinity. Here it is 1 by 2 pi minus infinity to plus infinity x of j omega. In place of omega, in place of t, 0 is substituted. E raised to 0 is 1. That is what is taken here. It is actually 1. Okay, so that's why you get only this much. What is x of j omega? Find out this equation, this equation, this equation, this equation, put it here and solve it. That's it. So from this here to here, omega plus phi, that we have already analyzed how it should be, and I have given you the task to find out the lines equation, straight line equation in the same manner. Solve it, simplify by yourself, take this task and cross check your answer whether you get this answer or not. That's it. Now, it's a solved problem in your textbook. Find the energy of the signal x of t is equal to e raised to minus t at u of t. Determine the frequency capital W rad per second, so that energy contributed by spectral components of all frequencies below W is 95% of the signal energy Ex. Ex is a total energy. Since x of t is equal to e raised to minus at u of t, its ft pair is 1 by j omega plus a, that we already know, and it's a Parseval relation. Now we have the solution. Ex is a total energy from minus infinity to infinity x square dt. So 0 to infinity, why I'm taking? Because it is u of t, 0 to infinity, e raised to minus 2 into uh, one second. Uh, yeah, why it is taken is, so it is e raised to minus 80 whole square it is. So that's why minus 2t is taken here. So if you take its integration, you get it as, I'll write it here, e raised to minus 280 divided by minus 2a, you get it as infinity to 0. If you substitute infinity here, it goes to 0. If you substitute 0, you get minus 1. Minus minus cancels 1 by 2a. That's why you get it as. Same thing, it has been asked to verify in the frequency domain. So we will do it. We will verify the Parseval's theorem. In frequency domain, it is x of j omega. X of j omega is equal to 1 by j omega plus a. So ex is equal to 1 by 2 pi. So 2 pi, why I am taking out, because 2 pi into 2, it is minus infinity to infinity. Here it is taken as 0 to infinity. 2 and 2 cancels. That's why it is like that. So 1 by omega square, 1 divided by omega square plus a square, because I have to square it. So I'll square it here. Mod, it is actually mod square. So I'm taking in this fashion. I have already explained this, how you get omega square plus a square plus b square is equal to mod of a plus b whole square. I have shown it in the third chapter, I guess. Same thing. So if I take its integration, your PUC2 or 12th standard says 1 by a tan inverse of omega by a. This is a trigonometric solution, 0 to infinity. So if I solve it, tan inverse of infinity minus tan inverse of 0. Okay, so tan inverse of infinity is pi by 2 minus tan inverse of 0 is 0. So pi by 2, pi and pi cancels. So only 2 will be left. So 1 by 2a. So this and this is matching. So Parseval's relationship is verified. It's verified. Now they have asked some additional questions. So what they are telling is only 95% of the signal is there from 0 to capital W. So that is nothing but 0.95 of total energy. This is total energy. 95% of total energy is nothing but 0.95 into Ex. So Ex is found out. That is 0.95 into 1 by 2a. 0.95 into 1 by 2a. So therefore 0.95 by 2a is equal to 1 by pi 0 to w, because they have taken till 0 to w. 0 to w, same equation, I'll solve it. I get it as same thing, tan inverse of omega by a. So same things, if I solve it, I get it as 0.95 divided by 2a, tan inverse of, so this a and this a cancels, pi I'll take it on the other side, tan inverse of w by a. So use your calculator. So tan inverse here, if I take, it will be tan of 0.95 pi divided by 2. Keep it in radians. You get it as W is equal to 12.706 into A. This A into A rad per second. Next one. So find the FT of the given signal. So here the solution goes like this. It is taken as x of t is equal to a of t convolved with b of t, where b of t is differentiation of so and so. Now we know that sine wt by pi t, its ft pair is in this fashion. So if you want to take its, I just take it with this sine 1t divided by pi t, it's as it is given. Its ft pair will be 1 from omega less than or equal to 1 and 0 otherwise. I can write it as minus 1 to 1. Similarly, if I want to write this sine 2t by t pi t, its ft pair would be 1 from omega less than or equal to 2, 0 otherwise. So your signal would look like minus 2 to 2. Okay. So now what I do is, in frequency domain we get multiplication. So when you multiply, the overlap will be from only this to this. So that is what you have to identify. So this d by dt of s of t, if I call this as s of t, so its ft will be j omega, capital S of j omega. Okay, so I can say that this j omega gets multiplied in the range. What is that range? It's the same range because this is the overlap. Minus 1 to 1. Only this is the overlap. So hence I have to take the boundary of the first signal, that is 1 omega less than 1, and multiply just j omega with it, because this comes with differentiation, hence j omega component comes multiplied with that. That completes your Fourier transform of the given signal. Next, last one. So x of j omega is given as j omega by 1 plus j omega square. So 1 divided by 1 plus j omega square, we know that its ft pair is t into e raised to minus t, because a's value is occupied by 1 u of t. So differentiation, j omega s of j omega is differentiation property. So hence I can write x of t as a differentiation of the given signal, this time domain signal. So that completes your answer. So you can differentiate it. So first t is kept constant, e raised to minus t, and u of t is kept constant. Differentiation of e raised to minus t is minus e raised to minus t, and then e raised to minus t u of t is kept constant. Differentiation of t is 1. So e raised to minus t u of t common is taken, so 1 minus t will be left outside. So this is the answer for inverse ft. Simple, quite simple problem. So this completes your problem section of Fourier transforms as well as inverse Fourier transform. So I hope there are no doubts. Thank you for listening.